So hi, today the main topic is the performance in web front-end engineering part. So why do we have to care about performance? Because actually you can really enhance the website performance in just only client side. Forget about also kind of API latency. Of course, if there's like API latency, there's gonna be also latency on front end the website part, but you can really reduce those kind of things. But the performance in the front end part is really kind of abstract. Because the performance issues could be your users your mobile issue, or there's gonna be network issue. And moreover, there's gonna be a cache issue, a render issue, and the React re-rendering issue. It's really kind of sad because a lot of people are trying to enhance their performance, but they only focus on the React rendering issue part. If you look at the performance in front end, this is really kind of small thing. Because this is gonna be really easy to understand. The performance isn't about just rendering issue. When you learn about some kind of how we get the website in the perspective of computer network. So how do we get the website? So first of all, you're gonna go to the browser, the Google Chrome or Safari or whatever. So you go to Google Chrome and you will type some kind of your URL or search query on the search bar in the Google. But the thing is that this is actually also the process is gonna be thread is gonna be working, because the browser is actually the application. The developer made this, and there should be some kind of thread or process. So if you look at the Chrome here, I'm just gonna screenshot for you. So if you look at Chrome, you will hit this kind of search query on whatever. So example, my website. So if you're trying to hit the my website first, because you're just basically go to the my website, you have to hit the MYWEBSITE first. The browser is gonna be trying to look at here, parse this kind of string and analyze, is this search query or it is going to URL. So if it's a search query, is pretty fine, but if it's a URL, it's gonna go different. So, but our goal is to get website. We're just gonna hit the URL. So if it's URL, the browser, and when you hit enter, this is kind of this part actually this kind of UI. We are using UI of the browser. So we are in the UI thread in the browser process. So, and then when we hit enter, and if it's URL, we have to use the network thread to hit network. This is kind of part that the DNS lookup is being made. Why do we have to think about DNS lookup? Basically, if the user he never or she never visited your website, they don't know the address of your website. Your website is basically handled by the server, static server or whatever server, and since if it's the first time, it doesn't know the IP address of it. Remember, your URL is just the human-friendly terms of it, but in the under the hood, there's the IP address to based on that. So there's a URL. You have to find your website server IP address, and browser we're gonna request that based on your IP address, and when you got response of the HTML and CSS JavaScript, we're just gonna render the page. So this is really hard work. So let's go to DNS lookup first. So DNS lookup is basically checking there's a cache or not. If it's not, go to DNS server, and if it's not, you go the top level DNS server. So example, there's your browser. You have to first check the cache here, because in the browser there's a cache on here. So look at the cache. If there's like the IP address that you wanna find, because my website.com, we're gonna have some kind of IP address. So you have to find it, because your website domain is gonna be key of your cache key. The value is gonna be IP address. So if there's no cache, you go to the DNS reserver. So DNS reserver is basically the phone book. If you look at the 90s, like 1970 or 1960, we don't have. I don't know. I didn't born in yet. So I heard they use phone book to find someone's phone number. So this key gonna be someone's name, or value is gonna be the phone number. So DNS reservoir is gonna be like that. There's a bunch of IP address and what the domain pairs, and we have to look at this DNS reservoir, which is kind of the phone book. Now we go to the DNS reservoir, and if it's not even this part, if there's some kind of IP address that we want to find, we go to the TLD, which is top level domain system. So TLD, we look at the TLD, and we just look at it. If this my website is .com or .net or .io. If it's .com, .com, it sends the IP address it sends the location of DNS that only has the .com. So if the website ends with the .com, you go to the corresponding DNS of that, and after that we find your IP address and next domain name system, but it will kind of like inside of the not inside relate to the your previous DNS, which is only contains .com. So you now get the DNS, which is you now go to DNS cloud or server, and we're able to get this kind of IP address. So basically this is not a real IP address, this is localhost IP address. I'm just gonna give you an example of it. So after that, you go DNS reservoir again, you cache it or you store in the DNS reservoir. You now go to you already get the IP address. Now this browser already get the IP address. Now you go to the servers, your website server, and you request I want HTML, CSS, JavaScript. And now we're gonna give you HTML, CSS, JavaScript, and after that you have to cache the IP address because you don't want to go to some kind of this complicated way. So you cache it, and that is how the DNS lookup does. After DNS lookup, you're gonna able to get the JavaScript, CSS, the HTML, and now this kind of broader process, the network friend, the broader process will kinda send the HTML CSS JavaScript to the render process main thread, which is gonna be able to render the page. So it's gonna send the message, the HTML CSS JavaScript via IPC, inter-process communication. So if you look at the performance in the front end, for example, to reduce those kind of way, you have to make some kind of cache here, or you even put the cache on here because browser automatically do it for you, but you have to really make a cache here, cache on the website server. If you always send some kind of like really heavy resource like image or video without cache control, make it no cache, the browser will just gonna do unnecessary request response even though response is the same. So if you look at the performance in the web front end, you have to think about network part. Example, if there's like cache control in it, now you have to think about cache control, and you have to think about JavaScript chunks cache control. If you look at JavaScript, basically our industry is using JavaScript chunks. If you look at the network tabs in like even the big tech company, there's like JavaScript chunks on it. Look at their names, and you'll be able to see their names is some kind of not encrypted. There's kind of some kind of unique value on there, some kind of unique numbers. But that is kind of actually the hashing on here. We hash the JavaScript chunks because JavaScript chunk is a file name, and we hash it. So every time we don't want to get the cache control, we want to do the cache control because there's already hash name, so there's no cache collision of here. So really kind of like performance on the web front end. And next part is re-rendering or prefetching. This is really how our website looks like. We're gonna launch it like August 4. Basically, if you look at here, drawing this kind of markdown is really kind of heavy calculation, or we have to use heavy JavaScript on it. And so to make it really kind of make it fast, we don't want to call API to get this kind of value when it goes to this page. So what we did was, when we're trying to mouse hover, or if the cursor is focusing on this card, we prefetch some kind of data, the related about that data. So if you click here, it's really already prefetching. There's no issue. Moreover, even though you ever look at this part, this is the data is this part. When we're trying to refetch it and remove, even though we remove this part, we remove the markdown content, but it is still there. The reason why it's still there, we just recache it using local storage. We just look at how ChatGPT do. So if you look at cache here, we cache like on the value part. So if there's no if there's like really bad network, we here don't have to see some kind of loading screen because we already cache it here. We just have to show the cache value first, and when we're just trying to refetch it, we just have to switch this kind of cache value and this markdown content. So it's kind of pretty good. So and after that, we maximize the prefetching and prefetch. Also, we prefetch this kind of JavaScript chunk of it. Click here. In this web page, there's gonna be massive JavaScript. To reduce to low JavaScript chunk, to go to this page, there's gonna be more JavaScript chunk. You have the parser and whatever thing. So to reduce this, we also prefetch the JavaScript chunks in the page. So in this, we hover this part, we prefetch the API for the necessary to render that page, and also we prefetch the HTML, JavaScript, and those kind of chunks. And hover it. So this is a really kind of basic part of how to enhance the performance in the web client part. So this is it. Have a nice day. See you next time. Bye bye.